there are problems no computer can ever solve. Not because we need better technology, but because they are impossible. So what if reality is one of them? There is a mathematical proof that some problems can never be solved. Not by better hardware, not by faster processors, not by future superintelligence. Never. Now, here's the uncomfortable question. What if reality itself is one of those problems? If the universe contains processes that no algorithm can reproduce, then no machine, anywhere, could ever simulate you. At least in principle, if such processes actually exist in physics. Not approximately, not eventually, ever. And if that's true, then the digital foundation beneath simulation theory doesn't just crack, it disappears. Tonight, we're going to the edge of computation, and we're going to ask whether reality touches it. First, precision. When we say something is computable, we don't mean easy, we don't mean practical. We mean this. There exists a finite procedure, an algorithm, that will produce the correct output in finite time. That's it. Computable does not mean fast. Computable does not mean efficient. Computable simply means there exists a rule-bound method that eventually works. And Turing proved something that shattered mathematical optimism. There exist well-defined problems that no universal algorithm can solve. One of them is called the halting problem. The halting problem asks, given any computer program and its input, can you determine whether it will eventually stop running? Turing proved there is no universal procedure that can answer that for all possible programs. Not because we lack cleverness, not because we lack memory, but because such a procedure would create a logical contradiction. That's not technological limitation. That's structural impossibility. Pause. If logic itself has edges, why assume physics doesn't? Here's where this stops being abstract. If reality contains even one physically real, non-computable process, then no digital system could fully reproduce it. Which means no simulation, no perfect rendering, no full emulation of physical law. And that should make anyone who believes the universe is just code at least slightly uneasy. But here's the critical constraint. As of today, no experimentally verified, non-Turing computable physical process has been demonstrated. Not in quantum mechanics, not in cosmology, not in neuroscience. There are arguments, there are interpretations, but no confirmed empirical case. That matters, because claiming a wall exists requires touching the wall, not imagining it. Some thinkers, most famously, argue that human consciousness may exploit non-computable physics. The reasoning is subtle. It connects Gödel's incompleteness theorem to human mathematical insight. The idea is that if the mind can see truths that no formal system can prove, then perhaps the mind itself is not algorithmic. It's a bold idea. It's philosophically rich, but it remains unconfirmed. There is no experimental evidence demonstrating non-Turing computable neural dynamics. Important distinction. Randomness is not non-computability. Unpredictable is not uncomputable. And many public discussions blur those lines. Now here's the twist almost nobody talks about. Even if reality is computable, it might still be impossible to simulate. Pause. Because computable does not mean efficiently computable. Simulating a few hundred interacting quantum particles already strains classical systems. Simulating every quantum interaction in a cubic centimeter of space would require astronomical resources, not infinite. Just absurd. So maybe the real wall isn't logical. Maybe it's energetic. Maybe it's about entropy. Maybe it's about information density. And here's the unsettling thought. If simulating the universe requires a universe-sized machine, what exactly distinguishes simulation from instantiation? At what point does a simulation simply become another universe? And if that's the case, are we even using the right category? Think about how humans have historically described reality. In the 17th century, it was a clock. In the industrial era, it was an engine. Now, it's a computer. Every age projects its dominant technology onto ontology. We built programmable machines, so we see programs everywhere. But projection is not proof. Calling the universe information does not mean it is executing code. Calling physical law computation does not mean there is a processor. Maybe nothing is running. Maybe reality is not executing instructions. Maybe it is unfolding constraints. Programs execute. Processes propagate. Programs require control. Processes require persistence. Programs step through states. Processes continue through conditions. And that distinction changes everything. Here's the line you can't unhear. If reality is a process, not a program, you are not being rendered. You may be being filtered. Filtered by physical constants. Filtered by cosmic inflation. Filtered by what survives long enough to stabilize. Filtered by what doesn't collapse. And filtering does not care. A programmer might care if you suffer. A process doesn't even notice. That's colder than simulation, because in a simulation, there might be intention. In a process, there is only continuation. So where does that leave us? The non-algorithmic wall has not been experimentally confirmed, but the limits of computation are real. Logical limits are real. Complexity limits are real. Energy constraints are real. And maybe the metaphor of code is too narrow to describe existence. Maybe reality does not compute itself. Maybe it propagates. And propagation doesn't require perfect calculation. It requires replication. Which means the deeper question isn't, can the universe be computed? It's, does the universe reproduce? Because if universes replicate through variation and selection, then we are not inside a program. We may be inside evolution. And evolution is far more indifferent than any machine. Next time, we leave computation behind, and we ask whether the cosmos behaves like life. Because if universes reproduce, we are not simulated observers. We are adaptive variables. And that is far more unsettling than living in code. I'll see you in the next episode.